Okay, we've got a metal cube, 4.5 centimeters by 4.5 by 4.5. It's going to be melted down and the metal used to make small spheres, each of radius 3 millimeters. Okay, so we're told that the side of the metal cube is to the nearest half a centimeter and the radius of the metal sphere is to the nearest millimeter. Now we have to find out the maximum number of spheres that can be made from melting down this cube. So we're trying to maximize this value. That doesn't necessarily mean that you have to maximize the value of the radius or the value of the side of the cube. You have to think about it a bit first, because we want the most number of spheres that we could possibly make. And that means the bigger the cube is, the more spheres you can make, and the smaller the sphere is, the more spheres you can make, because the smaller the sphere, the more you can get out of the cube. I'm sure you see what I mean. Okay, so the first thing to do is to work out what value of the side of the cube we're going to work with and what radius of the sphere we're going to work with. If you want the cube as big as possible, and the side is 4.5 centimeters to the nearest half centimeter, then the largest possible value that could be, if it's the nearest half centimeter, must be 4.75 centimeters. Because it could be as low as 4.25 or as high as 4.75. Anything bigger than 4.75 to the nearest half centimetre, it would be rounded up to 5. But we're told it's 4.5, so that is the value that we're going to work with for the side of the cube. We've made it as big as we possibly can, given that it's to the nearest half centimetre. And likewise, we're told that the sphere's radius is 3 millimeters. And we want to make that as small as we possibly can. So to the nearest millimeter, it must therefore be 2.5 millimeters. Anything lower than 2.5, it would be rounded down to 2 millimeters, not 3. So 2.5 is the minimum possible radius. Okay, so we've maximized that, we've minimized that. And now we can work out how many spheres with this radius we can get out of a cube with that side. So, volume of a cube, well, so the volume of the cube is just length times breadth times height, which is 4.75 times 4.75 times 4.75, which is 4.75 cubed. And I'm working in centimetres here. You can work in millimetres if you want, doesn't really matter. I've just started with centimetres, so I'll continue. And that is 107.171 something something something. Put it in your calculator's memory. Okay, cm cubed. Right, volume of a sphere. I hope you know the formula for the volume of a sphere off by heart. It's 4/3 pi r cubed. Now, we've chosen to work in centimetres, so we need to convert 2.5 millimetres into centimetres. Well, 2.5 millimetres is 0.25 centimetres. So 4/3 pi r cubed, radius cubed is 0.25 cubed. Stick that in your calculator and you get 0.065 something 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 cm cubed. Okay, we've got the volume of the box, cube, we've got the volume of the sphere. So if we divide the volume of the cube by the volume of the sphere, we can work out how many spheres we can make. So we do 107.171 whatever, dig it out of your calculator's memory and put that in your calculator's memory when you did the calculation as well. Now dig that out of your calculator's memory, 0.065 something something something, and you get 1637.465 something something something. Okay. It wants the maximum number of spheres we can make, which means we can't have 0.465 of a sphere, so we're looking for an integer number, answer. So it's 1637. There you go. So remember, with these sort of questions, you don't necessarily maximize all the values you're given. They gave you 4.5 centimeters to the nearest half centimeter, and they gave you the radius 3 millimeters to the nearest millimeter. So don't just dive in and maximize both of them if you're looking for a maximum value of something. You need to think about it first. We maximize that and we minimize that to get the maximum number.